Okay, welcome to chapter 6. It's about rational exponents. And so we're going to use the same properties for exponents, but we do need to review how to multiply fractions because you will use that. Rational exponents mean fractional exponents. So when we multiply, if we were to multiply 3/4 times 1/2, remember to multiply the top with the top, so that's 3 times 1. And then the denominators together, so 4 times 2, and that would be 3/8. And you will be needing to know how to do that. When we add or subtract, we need to find a common denominator. So if we were doing 3/4 plus 1/2, we need to keep, it's basically how many you have on top to the name in the denominator. So when we add or subtract, we need to have the same name. So we're going to take 1/2 and multiply by 2/2, which changes the form but not the value of the fraction. So we will still have 3/4, and then when we multiply fractions, remember the top with the top and the bottom with the bottom. So that will be 2/4, and then we keep that same name, and then we'll add or subtract the top, and in this case it's 5/4. So you'll need to know how to do that. All right, so this key concept, real nth roots of A. So pause the video, read through that. And then what this means is this n is an even integer. So nth roots. So that would look like if n was the root. So normally we deal with square roots. With square roots, we don't actually put anything, but there should be a 2 right there. This would be a cube root of A. So in this case, the 3 is an odd integer. So we have 4th roots of A, and then nth roots of A. So that's what it's talking about. So when we have square roots and 4th roots, n is an even integer, and when the number is less than 0, there's no real roots, and this is why. So if we had x squared equals 9, say x squared equals 0, 0, and x squared equals -9. Well, when I take a square root, which I'm going to take a square root of that, square root of this, that is an nth root, and n is even because it's 2. So this turns into plus or minus 3, right? So when a is greater than 0, so in this case a was 9, we get 2 real roots, and you already kind of know how to do that with Algebra 1. Okay, so let's do it when a is equal to 0. So when I square root both sides to solve for this one, square root, I get x equals, well, the square root of 0 is just 0. So when a is equal to 0, there is only one real root, and that happens to be 0. Right? When I do x squared equals -9, when I go to square root, and we're just going to deal with real roots, so no imaginaries, then x is going to be equal to no real solution. Okay. We know it's plus or minus 3i, but there's not a real solution. So when the number is less than 0, in this case it was -9, we have no real roots, right? And that applies to 4th roots, 6th roots, so any even number. Okay, for odd numbers, we kind of dealt with this a little bit, but we can do an example. So if you have, let's say we have x cubed is equal to 8. We can also do x cubed is equal to 0, and x cubed is equal to -8. Right? So we're going to do the positive case first. So to get rid of the cube, we're going to cube root both sides. So cube root, so cube is 3, and that is odd. And there's only one number that will work. The cube root of 8 is +2. It can't be -2. So that is one real root. In this case, it would be 2. All right, if I go to the next one, x cubed equals 0, if I take the cube root of both sides, then x is going to be equal to 0. So if the thing under the radical is 0, then we have one real root and it's just 0. And then for the x cubed equals -8, if I take the cube root of both sides, well, this becomes x, and this is -2, because -2 times -2 times -2 equals 8. So I have 3 of the same thing. And that means I have one real root when the number is less than 0, so a negative number. So that kind of explains that a little bit, but keep those in mind. So for example 1, we have the cube root of -216. All right, so that is an odd number. It's an odd number for n, and it's a negative under the radical. Right? So, and we can also rewrite it like this. This also means the same thing. And so either case, you would get -6, right? One real root. Right? For example B, we would put this would be the fourth root of 81. We could also put it as 81 to the 1/4 power. Those are equivalent. And then, so we're looking for basically a number times itself 4 times that multiplies to 81. So that would be 3 times 3 times 3 times 3 equals 81. We could also do -3 times -3 4 times, and that also equals 81. So we have, this is even, and this is positive, so we know it's 2 real roots, and we found them. It's plus or minus 3. Right, here's a key concept, which I kind of touched on. So rational exponents, a to the m over n, we can break that down. Sometimes that's helpful. So if I have x to the 2/3 power, sometimes it would be helpful to rewrite it as, this would be x to the 1/3 times 2, right? Again, when you multiply fractions, we multiply, and so we get 2/3, so we're just going backwards. But this is the same thing as the cube root of x squared. So sometimes it's helpful to write it like this, and sometimes it's helpful to write it like this. Same idea with the next one, but we have negative exponents, so everything goes downstairs. All right, so when we evaluate just means to simplify, make smaller. So we have 16 to the 3/2 power. Again, that doesn't make much sense right now, so we're going to break that down a little bit. So this is the same thing as 16 to the 1/2 power cubed. And 16 to the 1/2 power, that's the same thing as the square root of 16 cubed. And I know what the square root of 16 is. That is 4, and then 4 cubed is 64. Right? So sometimes it's helpful to rewrite it. For part B, we have 32 to the -3/2 power, which means that's a negative exponent, so that is going downstairs. So 1 is going to be in the numerator. And then we have 32 to the +3/5, so now it's happy. Again, 32 to the 3/5 doesn't mean much to me, so I'm going to break that down into 32 to the 1/5 power, and then we're going to cube that. Right, that is the same thing as the 5th root of 32 cubed. Right. And the 5th root of 32, I'm basically looking for a number multiplied by itself 5 times that equals 32. And so that would be, let's see, 2 times 2 times 2 times 2 times 2 equals 32. So I found my answer. So this is going to be equal to 1/2. Okay, the 5th root of 32 is 2, and then I'm still going to cube it. So that would be 1/8 for my final simplified answer. Here is just approximate roots with a calculator. Your calculator may work differently. We can definitely help you in class with that, but try these, pause these, try these, and then make sure you get the display. If you do not, I can help you in class. Right, guided practice. Here, so 5 through 8, make sure you don't use a calculator. You're going to break it down for something that makes sense, just like we did. And then 9 through 12, you are using your calculator. Okay. Example 4, solving equations. So very similar to quadratics, we want to get the thing being, for a, we want to get x to the 5th by itself. So the first thing we're going to do is divide by 4. So we have x to the 5th is equal to 32. And then what gets rid of a 5th is to the 1/5 power, or we can do the 5th root. Right? So the 5th root undoes the 5th. And so on the left we get x. This side, let's see, we have an odd root, so we only have one real root, and that would be 2 because 2 to the 5th is equal to 32. Right? For b, I'll write that a little bit bigger. We have x minus 3 to the 4th equals 21. Right? And so we have the thing by itself. So I'm going to do the 4th root to both sides. The 4th root undoes the 4th power, so all that goes away. And on the left we get x minus 3. Over here I can't break down, there is no number multiplied by itself 4 times that equals 21. But this is an even root, so it's going to be plus or minus the 4th root of 21, which I'll leave like that. And then I'm going to add 3 to both sides. Those aren't like terms, so I can't combine them. So x is going to be equal to 3 plus or minus the 4th root of 21. And that is both of those examples. Okay. So pause, read the word problem, and figure out what's going on. Okay. All right, so let's see. W is equal to weight. And then L is the coral cod's length. Okay. So we're going to estimate the length of the coral when it weighs 200 grams. So we're going to put that in for W. So we have 200 is equal to 0.0167 L cubed. All right, so the first thing I want to do is get the L cubed by itself. So I'm going to divide everything by 0.0167. Okay, so when I do that, I have L cubed on this side, and when I divide, I get this number, almost 12,000. Okay. All right, so from there, since it's real life, we're going to use our calculator. And then to get rid of the cube, I want to cube root both sides. Right, cube root means it's a word problem, so I want the positive answer, but this only gives me one real root. So the length is going to be equal to about 22.9 centimeters. And that is how you do that problem. So with guided practice, number 14, you want to multiply by 2. It's a lot easier than dividing by 1/2. Similarly with 16, you want to multiply by 4. All the rest look okay. 19, again, these are the weight, so it's just practicing using your calculator a little bit, and that is the end of that lesson.